Okay, you guys, so today we're going to finish up, do a little quick video on the last page of your notes that I have to finish. So estimating population standard deviation or variance. When considering estimates for proportions and means, we use normal distribution and student t distributions. Okay, so that's our z tables and our t tables. When developing estimates for variance or standard deviation, we used another distribution called chi-squared. So now we're going to use chi-squared distribution, and oftentimes you'll see it symbolized like that. That's the symbol for chi-squared. Okay, and then you see it right there. Okay, so it's like a cursive, or like not a cursive X, but like a wavy X with a squared. It doesn't mean you square your answer. It's already all built into this formula. So this is the formula we're going to be working with. This is how I find values in my chi-square distribution. It has degrees of freedom of n-1, very similar to t distribution. So attributes of chi-square distribution. The shape of the distribution is not symmetric, and in fact, it looks something like this in general. That's kind of the idea behind it. The degrees of freedom is n-1. The values of chi-squared. Chi-square can be 0 or positive, but they cannot be negative since they're talking about standard deviation, and approaches the standard normal distribution when degrees of freedom are large. Just like in t distribution, if you get a very large n, you basically start getting normal distribution. Okay, so requirements for the estimates and variance and standard deviation. The sample is a simple random sample. That's pretty standard for us. The population is normally distributed. If don't know about the population, check shape of data. So the population is normally distributed. In general, they give us some information. In moving on in later sections, we're going to start working with other stuff. So here's how we build confidence intervals. So for our class, I'm not really going to focus on this guy. So we're going to focus much more heavily on confidence intervals just for standard deviation. We're not going to worry too much about variance, but once again, if you know how to do it for variance, for standard deviation, you would know how to do it for variance as well. It's just, I'm going to focus on standard deviation in this class. Unlike confidence intervals for means and proportions, the critical value will be different on the lower and upper end because chi-squared chi-squared distribution is not normal. Okay. What it also means is it's basically saying it's not symmetric. Okay. So when you think of this curve, the value here will not have the same shape as the value over there, right? So just keep that in mind. Okay, so let's take a look at this example problem. And again, we're going to spend more time on this in chapter 8, 9, and 10. But this is just kind of a preview of what's to come. So we kind of get comfortable using chi-square distribution. So it says the proper operation of typical home appliances requires voltage levels that do not vary much. And that makes sense. You don't want it to have, out of control variance in its voltage levels. Otherwise, it could cause problems in the house, cause fires, things like that. So it said listed below are 10 voltage levels in volts recorded at a home on 10 different randomly selected days. Use the sample data to construct a 95% confidence interval for standard deviation of all voltage levels at this home. So first things first, let's check the requirements. So is it random? Check, because it said listed below are 10 voltage recorded at a home at 10 different randomly selected days. So we got random. Let me see here. Where does it say? Use a sample. The proper operation typical home appliance requires that the levels are that do not vary much. Listed below are 10 voltage levels in volts recorded at 10 different randomly selected days. Use the sample data to construct a 95% confidence interval standard deviation. Well, they don't mention that it's normal, but we're just going to have to assume it is for this particular problem. Otherwise, we could not work with it. Okay, so I'm just going up here off what they say our requirements are. Okay. So I'm not going to check the shape of the data. I'm going to kind of assume that it is, otherwise they wouldn't ask me to do it. And then it says, get the chi-squared critical values from the table. Okay, so what we need to do is we need to realize this is our chi-squared right, and this is our chi-squared left, okay? So we're gonna find these critical values using the table because our calculators don't have as many chi-squared features as normal, okay, as we usually do. So I'm gonna take out my calculator and I'm gonna plug each one of these values into the calculator, okay? and I need some information. So it says here, to get chi-squared, okay, to get our chi-squared value, we have to do, let's see here, or I guess, yeah, I guess I could do it that way. I was just going to go straight to it and do the values, but I'll split it up into pieces. Like the problem is, I'm going to run out of room, so I'm going to bring this down here, you guys, okay? So if we're going to get the chi-squared critical value, so I want to find chi-squared right, and I want to find chi-squared, chi-squared left, okay? So in order to find chi-squared right, we have to think about this graph. Okay, and I don't know where exactly it is. I'm just going to call that there, and I'm going to call that there. Now this is chi-squared right because it's on the right-hand side, and this is chi-squared left because it's on the left-hand side. That's all there is to it, okay? Now how much area is in here, and how much area is in here? Remember, this is a confidence interval, so it has two tails. Well, they said that they want to use a 95% confidence level. So that means there's 0.025 there and 0.025 there, okay? Now, we're going to go over here to the table. So I should have this table posted on, I believe this is on Canvas. So go ahead and look on Canvas in the module and you should be able to see it. So let's go to chi-squared. Okay, so here's the chi-squared distribution. And I want you to notice right here that it says area to the right of the critical value. So that means that when you're drawing your picture, right, normally everything used to be in z-scores and t-scores. We were always working with those on our calculator or on the table. It was always telling us the area to the left, okay? However, with chi-squared, it tells you this is the area to the right of the critical value, okay? So what I'm going to do is I'm going to first find my chi-squared right. So I'm going to put chi-squared right here. And then I'm going to shade to the right because this is the easier one. Okay, so how much area is to the right? We know it's 0.025. So I go on my table and I say, how much area is to the right? Well, 0.025. And then what's my degree of freedom? Well, I believe there were 10 scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 scores. So I have a degree of freedom of 9, right? Because it's n minus 1. So I'm just going to go over to here and I'm going to go over to here. So I get chi-squared right is worth 19.023. So I'm going to use 3 decimal places. Now we come over here. Now here's a problem because we know that this area here is 0.025, but the table doesn't work like that. The table doesn't do area to the left. So what we have to do is we have to outsmart the problem. We have to say, okay, well, if there's 0.025 to the left, how much is to the right here? How much area is to the right? Well, I'm just going to do 1 minus. So I'm going to do 1 minus 0.09. 1 minus 0.025, and I get 0.975. So that means the area to the right is actually 0.975 if there's 0.025 to the left. Okay, does that make sense? Hopefully, if not, you can ask me about it in class. So now what we have to do is we go on our table. Okay, and let's find chi-squared left. So this is chi-squared left. So we're going to find this guy, and we're going to do the table for 0.975 and then go down to 9. Okay, so let's see what number this is right here. And this is 2.700. Okay, so we got 2.700 and 19.023. So now I'm going to come back over to here. Oops, sorry about that. So I now know that my chi-squared right is worth 19.023, and my chi-squared left is worth, what did I say, 2.700, okay? So we found both of those values, okay? So now what we can do is if we look at the formula says if you want to find the confidence interval, you set this up. So I'm going to construct my confidence interval. Let's go over here so I don't run out of room once again. And I'm going to do the square root of n minus 1, which would be 9, times the standard deviation. Now, here's the problem. Remember earlier when I said, enter this into your calculator in your list? Now we have to go into our list, just like before, and we do stat. You plug this into your calculator, then you go stat, and then so stat calculate on your calculator, and then you go into one variable stats, right? And hit enter. Okay, hit enter a couple times. And so we get some data. It says that we're going to need S, and we're going to need, I guess that's it. That's all we need. We just need S. Okay. So, I guess we're going to need X bar as well. So I'll put that here. X bar is worth, and you know what, from calculator. So this is just kind of our not our scratch work, but this is information we need from calculator. Okay, we have X bar is worth 123.53. And then we have S is worth 0.149. Okay, so now, yep, that's what I got, 0.14944 something. But so now I can use this information to build my confidence interval. So it says, I'm on this one right here, you guys, I'm doing this one. I'm n minus 1 times S squared. So this would be times 0.149 squared divided by chi-squared right. So we know that chi-squared right is 19.023. And then we know that the standard deviation of the population, sigma, whatever it may be, we're not exactly sure, but we're building the interval for it. And then we're going to go over here and we're going to do 9 times 1.149 squared divided by chi-squared left, which we know is 2.700. Okay, and make sure when you're plugging this in the calculator, you're very careful. This whole thing, should be in some kind of parentheses. So the whole thing is square rooted, or you could choose to do all of it and then square root your answer. But let's see what we get when we plug this into our calculator. Okay, so I'm going to do 9 times 0.149 quantity squared divided by 19.023, and then I'm going to square root that answer, and I get 0.102, I guess we'll do, since we use 3 decimals on the other one. And then we know that sigma is in between this, and then we're going to do the other side, 9 times 0.149 quantity squared divided by 2.7, and then I'm going to square root that, and I get 0.0. I think I did something wrong. Yep, hold on. Oh, I forgot to square it. I'm sorry. So 9 times 0.149 quantity squared divided by 2.7, second function, square root, second function, answer. Yep, sorry about that. I knew something was wrong because this number should always be smaller than this number. And I got 0.272 if we round off to 3 decimal places. So my confidence interval is 0.102, 0.272. So this is the correct answer, and this is also the correct answer, just 2 different ways of looking at it. So you would say, I am 95% confident that the population standard deviation is between 0.102 and 0.272 volts for household appliances. Okay, so get used to writing stuff like this. That's a lot of what this next chapter is going to be. So this is required on the exam. You guys, if you're taking the exam online, you will be required to do like the drop-down menu like they use, and you have to come up with a good sentence. If you're taking it with me in class, depending on if we're back from COVID yet, you would, have to write this literally on your exam, and I would mark off points if you did not do it. So just get used to writing a conclusion. I am 95% confident. I am 99% confident, so on and so on and so on. That's what this chapter is about, is starting to learn how to use the math for something instead of just, just doing calculations. Okay. So again, I don't want to spend too much time. We're going to do a lot more, or not a lot more, but some more of this in chapter 8. So here you go. And that kind of helps you use your table as well. All right, you guys, that's going to do it for this video. That should get you started. If you have any questions, let me know.